Hi everyone. So last lesson we did circuits, and we just looked at the basics of circuits, how current flows. We looked at conventional current versus what goes into reality and the different components of the circuit. Today we're going to do current, which is the flow of electrons. Current. Okay. And the symbol for current is I, and it's measured in amperes. A. Okay. So, from the last lesson, we learned that current flows from positive to negative. Okay. So, we're looking at these electrons and they're flowing around the circuit. Now, each electron carries a charge. Okay. An electron carries a charge, little charge Q, of 1.6 times 1,602 times 10 to the minus 19 coulombs. So that is the charge of one electron. So if you can think, if an electron was a motor vehicle and the passengers were charged, the electrons are carrying those passengers, which are the charge. And those passengers, they represent, or they amount to 1,602 times 10 to the minus 19. So when we think of the flow of electrons, right, which is like, that's why they call it current, because current flows. We can also think of that as the flow of charge. So we basically have charge flowing. And that's why we get this equation, Q equals I times T. Charge is equal to the current multiplied by the time. So if you have more current, you have more charge. If it flows for a longer period of time, more charge is going to have flown. And I don't know if you guys use these triangles, but it's a much easier way to then do the equation, because if you wanted to work out current, I, you could say I is equal to Q over T. And if you wanted to work out time, well, that would be Q over I. I'm not going to write that down. So that's current. Current is the flow of electrons, which ultimately is the flow of charge. Now, when we look at this circuit and how current flows, it's important in these questions to know what is current doing? How does it behave? So if I start at the battery, right, the current starts to flow, okay? And it flows through the ammeter, and the ammeter measures the current. So an ammeter is the thing that measures the current that's flowing through. So it'll know exactly how much current. So if my current in the circuit was 1.2 amps, then this measurement here would be 1.2 amps. I just need to put in. Okay. Now, when it gets to these parallel resistors, it splits. The current splits up. So it's almost like when we think of current flowing water, it gets to two pipes, it's going to split up. And so the current is going to change along each pipe. Orange. Okay, so orange and red represent different amounts of current. The 4 ohm resistor is going to have the most current flowing through, because current wants to flow through the path of least resistance. So if I'm walking along the street and there's 2 alleyways, I see a whole lot of gangsters on this alley and there's no one along that alley. Or maybe there's just one gangster. I'm going to go and get murdered by one gangster rather than murdered by a whole lot of gangsters. My wife just walked in and I don't think she thought that was very funny. Now, when we get back to the single wire, the current now joins and becomes the same as it was at the beginning. So, my ammeter readings on A1 and A2 are exactly the same. So even though A1 is at the beginning of the circuit and A2 was at the end, the current doesn't get used up. So if you think of a river flowing, as long as nothing's taking that water out that river, it's going to be the same at the end. So we know that A1 equals A2. And we know that the current going through the 4 ohm resistor is going to be greater than the current in the 6 ohm resistor. Okay, next in 2 lessons time, we're going to learn how to calculate the current on the different resistors in parallel. But for now, that's all you need to know, and we'll be doing voltage in the next lesson.